In this video, I'm going to show you how to convert these partial differential equations into ordinary differential equations. So let's go ahead and start with the first one. All right, so we'll start by assuming the following, that our solution u is a function of x and t. And we're going to assume this is a product of a function of x times function of t. So x of x, t of t. So x is a function of x, t is a function of t. Now for simplicity, we'll just write this as big X times big T. And we'll keep in mind that the big X is a function of X and T is a function of T. Now we need to compute their partial derivatives. So we need this partial derivative and this partial derivatives. So we'll find the partial of u respect to T. So we'll differentiate this piece respect to T. Keep in mind that X is a constant. So you'll have X times T prime. And then we need partial of u respect to x. So now t is treated as a constant, so you'll have x prime times t. Now we need u sub x. So that's the second partial derivative respect to x. So you'll have x double prime times t. All right, now we're going to take these pieces and substitute. So we'll take this and substitute into the given equation. So it's this one. All right, so here's what we're going to have. So we're going to get t times u double prime, that's going to be x double prime t, plus little x times u sub t, that will be big X times t prime equals to 0. All right, now here is where you want to separate the variables. So you want to have function of x on one side, function of t on the other side. So let's do that. So we're going to go ahead and move things around a little bit. So I'm going to go ahead and subtract this term on both sides. So you'll have little t times x double prime times big T is equal to negative little x, big X times t prime. And then I can isolate my variables by doing the following. So I'll divide both sides by, we could do, I guess we could do this, divide by little t, big T, divided by little t, big T. So you'll have x double prime times, well, x double prime, just that, is equal to negative little x big X times t prime over little t big T. And now I can move the x and big X to the other side by dividing. So we can keep the negative on either of the sides. So I'll keep it on the right side as it is. So we'll have x double prime over little x big X is equal to negative t prime over little t big T. Now only when these two equations are equal if they're equal to a constant. So we're going to call it equals to lambda, where lambda is a constant. Okay, so now we're going to split this up into two ordinary equations. So we'll take this equation, set it equal to lambda, and solve for it. So one will have this setup, x double prime over little x, big X is equal to lambda. Multiply both sides by little x and big X. So you'll have x double prime is equal to little x times big X times lambda. So since lambda is a constant, I'll just put that in the front. And then move everything to one side, set it to 0. So you can also express this as x double prime minus lambda times little x big X equals to 0. All right, so that's one of our ODEs. The next one we'll get by setting this equal to lambda. So our next ODE is going to be derived from negative t prime over little t big T is equal to lambda. Then move everything to one side. We can multiply both sides by little t big T. So we're going to get negative t prime is equal to lambda times little t big T. And then we can move t prime to the right-hand side to set it equal to 0. So we'll have t prime plus lambda times little t big T equals to 0. So there you have the second ordinary differential equations. So we have used the separation of variable to express this partial differential equation into two ordinary differential equations. All right, here's our next equation. We're again going to use the separation of variables to express this partial differential equation into two ordinary differential equations. So please go ahead and try it on your own first. Let me show you how to do it so you can check. Since I see my independent variables are x and y, so I'm going to assume that our solution u is a function of x and y, and u is going to be x of x and y of y. So x is a function of x, y is a function of y. For simplicity, we'll write this as x times y. All right, so we need now second partial of u respect to x and also respect to y. All right, so let's go ahead and do that. So we'll take partial of u respect to y. So x is treated as a constant. That would be x, y prime, and then partial of u respect to y again. So that will be x, y double prime. Then we're going to need partial of u respect to x. Now y is a constant, so you'll have x prime times y. And then we need u sub x, the second partial of u respect to x. So it'll be x double prime times y. All right, now let's substitute these into our given equation. So we'll substitute this expression and this expression into the ODE and also our assumption u, which is a product of x and y. So we will have u sub xx, that's x double prime times y, plus u sub yy, that'll be x, y double prime, plus little x times u is x times y, setting it equal to 0. All right, now we use the separation of variables. So here's what I'm going to do. Now I see that this term and this term involves y, so I can factor out a y. So containing, looking at only those two terms. So factor out an y from these two, you'll have y times x double prime plus little x big X plus big X times y double prime equals to 0. All right, now here I can subtract this term from both sides. So you'll have y times x double prime plus little x big X is equal to negative big X times y double prime. And now I can separate the variables finally, so I can divide. I'm going to go ahead and divide by y and also divide by x. And you can keep the negative in whichever direction you want. I think I'm going to keep them with x. So here's what I'm going to get. I will have x double prime plus little x big X divided by negative x is equal to y double prime over y. And then we set this equal to lambda, where lambda is a constant. All right, so now we split it up into two separate equations. So we'll have this equal to a lambda, and then we'll have the y variable equals to a lambda. So one ODE would be the following. So you'll have x double prime plus little x big X over big X negative equals to a lambda multiplied by negative x. So you'll have x double prime minus little x big X plus lambda big X equals to 0. And here you can pull out the big X, so you can also rearrange. This is y double prime. Can write this as plus little x. Sorry, looks like I messed up a sign. This should be a positive sign. Sorry about that. Little typo. So plus lambda times big X is equal to 0. So that's one of my ODEs. And then my next ODE would be taking this one, setting it equal to lambda. So we'll have y double prime over y is equal to lambda. And then moving everything to one side and multiply by y, you'll derive y double prime minus lambda times y equals to 0. So there you have your next ordinary differential equation. So there you have it. We're able to use the separation of variables again to convert that PDEs into two ordinary differential equations. All right, I hope this helped. I'll see you next time. Take care, everyone.